Welcome back to our Python Essentials series. Today, we're diving into a crucial foundation of coding in Python, variable naming conventions. When it comes to naming variables in Python, there are a few rules and best practices you should always follow. Firstly, your variables should only contain letters from AZ and AZ. This keeps your code clear and free from unexpected errors that special characters might introduce. Next, remember that variables cannot start with numbers. While number 1 is valid, one number is not, and Python will throw an error. Python is case-sensitive. This means that lowercase and uppercase letters are different in the eyes of Python. For instance, ABC and ABC would be considered two separate variables. Beware of reserved keywords like int. These words have special meaning in Python, and using them as variable names can cause conflicts in your code. And finally, it's good practice to follow the Python convention of using lowercase letters for variable names, separated by underscores for readability. For example, user_name instead of username or username. In Python, one of the most powerful features is the ability to import packages. But before we can use them effectively, it's important to understand what packages really are. Think of a package as a directory of Python modules. It's like a folder on your computer that contains a special file named __init___.py. This file tells Python, hey, this directory is a package, and it can contain one or more modules. Modules are simply files containing Python code that can define functions, variables, and classes. When these modules are organized together in a package, they typically share a common goal or purpose. For example, when you type import math, you're bringing in the math package, which includes a variety of mathematical functions and constants. After importing math, we can access its attributes. For instance, math.py gives us the value of pi to a high degree of precision, as you can see on the screen. Packages are essential because they allow us to leverage a vast ecosystem of pre-written code, which can drastically speed up development time and extend the functionality of Python. Python's control structures are fundamental to writing effective code. They determine the flow of execution in a program, and there are three main types. First, we have the sequence structure. This is the default mode of operation in Python, where instructions are executed one after another, exactly as they appear in the script. Next is selection. This control structure allows the program to choose between different sets of statements to execute. This is how a program makes decisions and performs actions based on certain conditions. Lastly, there's repetition. This structure is all about looping, enabling a block of code to be executed repeatedly. Whether it's iterating over items in a list, or performing an action until a certain condition is met, repetition is a powerful tool in Python. Understanding these structures is key to mastering Python programming, as they are the building blocks for creating complex and efficient scripts. In Python, if statements are a fundamental control structure that allows for conditional execution of code blocks. The syntax begins with the if keyword, followed by a condition that is evaluated by Python. If the condition is true, the indented block of statements beneath the if statement is executed. It's essential to note that indentation is critical in Python. The standard is to indent the code block by 2 spaces, which creates a visual hierarchy and indicates that the code is part of the conditional block. Now, looking at the flowchart, when Python reaches the if statement, it checks the condition. If the condition evaluates to true, the flow of execution continues down the path to the statements block, where the instructions within the indented block are run. If the condition is false, the statements block is skipped, and Python moves on to the next part of the code. Remember, the if statement is a powerful tool, and mastering it allows you to control how your programs behave under different conditions, making your programs more dynamic and responsive to user input or other data. In Python, the if-else control structure allows us to execute different blocks of code depending on whether a condition is true or false. The syntax starts with the if keyword, followed by a condition. If the condition evaluates to true, the first block of statements, labeled here as statements_1, is executed. If the condition is not true, the program skips statements_1 and executes the block under else, referred to here as statements_2. It's important to maintain consistent indentation to define which statements belong to the if block and which belong to the else block. Typically, Python-style guides recommend using 4 spaces for indentation, which is also Python's default. Looking at the flowchart, you can visualize this decision-making process. The program evaluates the condition. If it's true, statement 1 is executed. If it's false, the flow of control jumps to statement 2. This structure is incredibly useful for writing code that must make decisions and perform different actions based on varying inputs or conditions. In Python, the elif statement stands for else if. It's used when you have multiple conditions to check sequentially and want to execute only one block of code that matches the first true condition. Here's an example using grades. When you're grading an exam, you might set up conditions based on the score to determine the grade. You'd start with the highest condition and go down to the lowest. If a student's score is 75 or higher, they receive an A. That's your first condition. But if it's not true, you move to the next condition. If the score is 65 or higher, then the grade is a B. If that's not true either, you check if the score is 45 or higher to assign a grade C. You continue this pattern with elif for as many conditions as you have. In this case, if the score is 35 or higher, the grade is D. Finally, if all previous conditions fail, the else statement catches everything else, and you assign a grade F to scores lower than 35. Nested if-else statements in Python allow you to check for multiple conditions and make decisions within decisions, which is essential for expressing complex logic. Let's consider a simple program that decides what you should be doing based on the day and time. On weekdays, which we're defining as any day with a day number less than or equal to 5, there's a different schedule before 9 a.m., before 6 p.m., and after. If it's before 9 a.m. on a weekday, it's time to sleep. If it's between 9 a.m. and 6 p.m., it's time for school. Otherwise, it's time for revision. However, on weekends, the schedule is more relaxed. If it's before 10 a.m., you can still catch up on some sleep. Otherwise, it's time to have fun. In code, we represent this with an if statement to check if it's a weekday. Inside this if block, we nest another set of if-else statements to check the time and decide the activity. If the day is not a weekday, meaning it's a weekend, we have another if statement nested within the else block for a different time check. This structure is how you can manage more complex decision-making processes in your code, allowing for greater flexibility and precision in handling different scenarios. Repetition statements, commonly known as loops, are a fundamental aspect of Python control structures. They allow us to execute a block of code multiple times, which can be incredibly efficient for tasks that require repetitive actions. There are 2 primary types of loops in Python, the while loop and the for loop. The while loop continues to execute a block of code as long as the condition is true. It's like saying, while this condition holds, keep doing these actions. Once the condition becomes false, the loop stops. On the other hand, the for loop is typically used to iterate over a sequence like a list, tuple, or string. It's as if you're saying, for each item in this sequence, perform these actions. Once the sequence is exhausted, the loop ends. Both types of loops have their use cases, and can be chosen based on what you need to accomplish. For example, a while loop is ideal when you don't know in advance how many times you'll need to repeat the actions, and a for loop is perfect when you want to perform an action for each item in a collection. The while loop in Python is a fundamental control structure used to execute a block of code repeatedly as long as a condition is true. The loop will continue to run, and the statements inside the loop will execute over and over again until the specified condition evaluates to false. Let's look at the syntax. You start with the keyword while, followed by the condition. After the condition, you include a colon and then, on the next line, start the body of the loop, which is indented. For example, let's say we have a countdown from 5. We set up a variable, count_down, with a value of 5. The while loop's condition checks whether count_down is greater than 0. If it is, the loop enters its body, prints the current value of count_down, and then decreases count_down by 1. With each iteration, count_down is reduced, and when count_down is no longer greater than 0, the loop exits, and the program continues with any code that follows. This is a simple yet powerful way to perform tasks that require repetition, such as iterating through items, waiting for a condition to be met, or continuously checking for user input. The for loop in Python is a versatile control structure used to iterate over the elements of a sequence. It's a convenient way to execute a block of code for each item in a sequence, which can be a list, tuple, string, or any other iterable. The syntax of a for loop begins with the for keyword, followed by a variable name that will hold the value of the current item in the sequence. After that comes the in keyword and the sequence you want to iterate over. Finish the line with a colon, and on the next line, write the loop's body, indented. For example, if we want to perform a countdown from 5, we could use a for loop with a range object, which generates a sequence of numbers. This will print the numbers 5 through 1. The range function starts at 5, ends before 0, and steps downwards by 1. Each iteration assigns the next number in the sequence to the variable number and then prints it. The range function in Python is a built-in feature used to generate a sequence of numbers. It's especially useful in for loops when you need to iterate over a series of numbers. The syntax for the range function is quite straightforward. It takes up to 3 arguments: start, stop, and step. The start argument is the value where the sequence begins, and it's inclusive. The stop argument defines where the sequence ends, and it's exclusive, meaning the sequence will stop before reaching this number. The step argument determines the interval between each number in the sequence. If we call range with a single argument like range 5, it will generate a sequence from 0 to 4. The start defaults to 0, the stop is the number we provide, and the step defaults to 1. This will print the numbers starting from 3 up to but not including 10, with a step of 4. So, it'll print 3 followed by 7. In Python, break and continue are 2 statements that change the flow of control in loops. The break statement is used when you want to exit a loop prematurely. It stops the loop's execution and exits out of it, continuing with the next line of code outside the loop. This loop will print the numbers 1, 2, and 3. When it reaches the number 3, the break statement is executed, causing the loop to terminate immediately, and then it will print done. On the other hand, the continue statement skips the current iteration of the loop and continues with the next one. It's like saying, stop what you're doing and start the loop over with the next item.